Advancements in simulation software for nanotechnology. Modeling and designing nanomaterials and devices. Nanotechnology is a branch of science and engineering that deals with the design, production, and manipulation of materials and devices on a nanoscale, which is typically defined as 1 to 100 nanometers, nm, in size. This is an incredibly small scale, as a nanometer is 1 billionth of a meter. Nanotechnology is an interdisciplinary field that draws from various branches of science, including physics, chemistry, biology, and engineering. It involves the study and manipulation of materials at the atomic and molecular level, which allows for the creation of materials and devices with novel properties and applications. Some examples of applications of nanotechnology include developing new materials with unique properties, such as increased strength, flexibility, or conductivity. Creating nanosensors for detecting and measuring chemical and biological substances. Designing drug delivery systems that can target specific cells or tissues in the body. Developing new electronic and computing devices, such as nanocomputers and nanorobots. Nanotechnology has the potential to revolutionize many areas of science and technology, and is already being used in a wide range of industries, including healthcare, electronics, and energy. However, there are also concerns about the potential risks and ethical implications of nanotechnology, particularly with regard to environmental impact and human health. There are many different software tools and packages used in nanotechnology, depending on the specific application and research focus. Some examples of software used in nanotechnology include molecular modeling software. These are used to simulate the behavior of molecules and materials at the atomic and molecular level. Examples of molecular modeling software include GROMACS, CHARMM, and NAMD. Scanning probe microscopy software. These are used to analyze and manipulate materials at the nanoscale using scanning probe microscopes, such as atomic force microscopy, AFM, and scanning tunneling microscopy, STM. Examples of scanning probe microscopy software include WSXM, Gwydion, and SPIP. Computational chemistry software. These are used to perform calculations and simulations related to chemical reactions, molecular structures, and properties of materials at the atomic and molecular level. Examples of computational chemistry software include Gaussian, VASP, and NWChem. Electronic structure software. These are used to study the electronic properties of materials, such as band structure, density of states, and electronic transport properties. Examples of electronic structure software include Quantum Espresso, Siesta, and ABINIT. CAD software. These are used to design and visualize nanostructures and devices. Examples of CAD software used in nanotechnology include SolidWorks, AutoCAD, and Rhino. Data analysis software. These are used to analyze and interpret data from experiments and simulations. Examples of data analysis software used in nanotechnology include MATLAB, Python, and R. Nanofabrication software. These are used to design and simulate the fabrication of nanostructures and devices using techniques such as lithography, etching, and deposition. Examples of nanofabrication software include L-Edit, CleWin, and NanoEngineer 1. Image analysis software. These are used to analyze and process images of materials and structures at the nanoscale, such as those obtained from electron microscopy and X-ray diffraction. Examples of image analysis software used in nanotechnology include ImageJ, Digital Micrograph, and Avisa. Simulation software for nanoelectronics. These are used to simulate the behavior of nanoelectronic devices, such as nanowires, quantum dots, and graphene-based devices. Examples of nanoelectronic simulation software include Nemo 3D, NextNano++, and Quantum ATK. Software for nanomedicine. These are used to model and simulate the behavior of nanoparticles and other nanoscale materials in biological systems, as well as to design and optimize drug delivery systems. Examples of software used in nanomedicine include MCell, NanoSim, and TUM-IAS. Software for nanotoxicology. These are used to predict and assess the potential toxicity of nanomaterials, as well as to study their interactions with biological systems. Examples of nanotoxicology software include DART, ToxPredict, and DSSA Toolbox. Cloud computing platforms. Cloud computing platforms such as Amazon Web Services, Oz, Google Cloud Platform, and Microsoft Azure are increasingly being used in nanotechnology research for high-performance computing and data storage needs. These are just a few examples of the many software tools and platforms used in nanotechnology research. As the field continues to advance, new software tools and platforms are expected to emerge to meet the needs of researchers in this rapidly evolving field. Thank you for watching. To know more about softwares regarding nanotechnology, visit http://vsic.in Softwares and Programming Languages.